Hello. Still awake? It's not even Sunday, come on. So, I just want to make a couple quick announcements. After this, the demo party begins. It has been moved to the Hardware Hacking Village, so please meet us in Hardware Hacking for the demo party later. You're saying to yourself, what are you going to demonstrate? I guess you have to show up and find out. Following that, at 6 p.m., ham testing happens in the Lockpicking Village. Do not be late because they lock the doors once testing starts. At 8 p.m. in this room is our banquet dinner and party. We're doing board game night again, so come have fun, eat dinner, and enjoy the party. Up next, we have Security Panda with HTTP2 and you.
Hello. So it's officially 16:03 PST time. I'm Security Panda, and thank you for joining me, and I'm happy that you're alive. And welcome to Talk Roulette. HTTP2 and you. This is part one, Bug Hunters and Pen Testers Guide to HTTP2. Can you guys hear me back here? Yeah? Okay, good. So, basically this is kind of my hope, is that security researchers will stop looking at HTTP 1.1 and look a little bit more at HTTP 2. So disclaimer is, everything stated in this talk is to be considered my opinion and not an official representation of my employer. Some assembly required, each sold separately, batteries not included. Keep out of the reach of small children. Also, don't test sites that you do not have prior permission to test, because we all know that would be bad, right? And I just also wanted to let you know that I've updated my security policy, and you are all consenting to my security policy by attending this talk. So a little bit about me. Who am I? My name is Brett Gravois. Some of you may know me from the Twitters as Security Panda. My email is panda@securitypanda.com. Feel free to send any comments or death threats or anything else, questions. So what do? I'm an application security enthusiast. My day job, I test pens, I break web apps, I make tasty food, and I own a majestic beard. So what are we going to talk about today? So we're going to go over what is HTTP2, the history, how it works, and what the current HTTP security landscape looks like. We're also going to cover finding HTTP2 ad hoc, finding HTTP2 at scale, go over what was found, and how to prevent future attacks. And so the question is why do I do this? Basically, I would like to raise awareness of HTTP2. Really, if you talk to a lot of developers, developers are kind of the hipsters. They like to go ahead and deploy things, set things up, and get it out on the internet, but they really don't read the RFCs, they don't look at the security implementations. And a lot of people, when telling them about what my research topic was on, they're like, oh cool, how do I deploy that? And kind of some of the methods that I'll show you, they're like, holy crap, I'm using HTTP2, I didn't even know. Also looking for new WAF bypass techniques, seeing if there's any old or new vulnerabilities. I'm not going to lie, make some money via bug bounty. And also, I like pain and suffering, and I've shamelessly stole this from Vis just to keep people from stop putting shit on the internet. So is anybody out there like a developer at all? Anyone? Okay. How many people are like application security people? That's a fair amount. How about pen testers? Bug hunters? I get a lot of okay. And then how many of you knew about HTTP2 prior to this talk? Yeah, there's a couple of you. Not too bad. Okay, so basically HTTP2 today. We've been using HTTP 1.1 since about 1997, 1999. And basically it's a protocol that's used on virtually everything on the internet. Basically everybody's making huge investments to the protocol and the infrastructure to take advantage of this. To the extent that it's often easier today to make things run on top of HTTP2 rather than reinvent the wheel and build something new on its own. HTTP inadequately uses TCP. So HTTP1 really has a hard time taking advantage of all the power and the performance that TCP offers. The clients and browsers have to be very creative to find solutions to decrease page load times, like using encryption like gzip or whatnot in the header. Other attempts have been going on over the years that TCP is not easy to replace, and thus we have to keep working on improving TCP and the protocols on top of it. Simply put, TCP could be utilized better to avoid pauses or wasted intervals that could have been used to send or receive more data, and highlight some of the shortcomings here later on. So basically, Google comes out with this thing called Speedy in about 2009. And it introduced header compression, which was vulnerable to the crime attack. It introduced multiplexing, it introduced the server push, and it was just HTTPS only. Which brings us to the HTTP2 protocol. Today, so basically HTTP2 was first published in May of 2015 as RFC 7540. By the end of the year, basically all the major browsers added HTTP2 support, and it's basically being used all across the internet. Sites like Google, Twitter, Facebook, and perhaps even like your company's page have HTTP2 enabled. And basically support is on Apache, Tomcat, Apache Traffic Server, Lightspeed Web Server, IIS, and Nginx. So HTTP2 is binary. It is a binary protocol versus HTTP 1.1 being ASCII. Binary makes the framing much easier. And the fact that the protocol features compression built in and will often run over TLS also diminishes the value of text. So basically you won't see text over the wire. So we have to basically be used to getting used to the idea of using something like Wireshark or a PCAP to figure out what exactly is going on at the protocol level. So the streams for HTTP2 are multiplexed. A stream is an independent bidirectional sequence of frames exchanged between the client and the server within an HTTP2 connection. A single HTTP2 connection can contain multiple concurrently open streams. Multiplexing the streams means that packages from many streams are mixed over the same connection. Header compression. So both HTTPS and Speedy had compression in the beginning that were vulnerable to breach and crime attacks. By inserting known text into the stream and figuring out how that changes the input, an attacker could figure out what's being sent in an encrypted payload. So basically, HPAC came out. Header compression for HTTP2, which as the name suggests is a compression format especially crafted for HTTP2 headers. It is being specified in a separate internet draft. The new format to get, with countermeasures should make it harder to exploit compression. Server push. This is a feature known as cache push. So the idea is basically that the client is asking for X, and the server will anticipate that the client is going to also need Y. So it'll go ahead and preload all of that info in one push. This includes like CSS, it includes any JavaScript, JPEGs, or HTML. It's something a client must explicitly allow the server to do. Even then, the client can swiftly terminate a push stream at any time. So then, we look at the HTTP2 handshake. So HTTP2 comes in two types. You have H2C, which is unsecure, and H2, which is over a secure connection. So over a secure connection, the client makes a request for an HTTP URL without the prior knowledge about the support for HTTP2. On the next hop, the HTTP upgrade mechanism, the client does so by making an HTTP 1.1 request that includes an upgrade header field with H2C token. H2C stands for HTTP2 clear text. So the request must include exactly one HTTP2 setting header field. So if you look right here, you see the upgrade to H2C. And so basically one of two things will happen. So the first one is if the server does not support HTTP2, you'll basically see your general what you're used to seeing 200 OK message. A server that supports HTTP2 accepts the upgrade and then replies with a 101 status code for switching protocols, and then it will upgrade the connection. The second one is over a secure connection. The client makes a request to HTTP2S used with the TLS with an application layer protocol negotiation, also known as ALPN extension, which is different from what you're used to seeing over just regular HTTP2S. So how does ALPN work? So ALPN is a TLS extension that includes the protocol negotiation within the exchange of hello messages. It's able to negotiate which protocol should be handled over a secure connection in a way that is more efficient and avoids additional round trips. And the ever-growing popularity of H2 makes use of ALPN to further decrease website load times and encryption connections faster. So basically, an ALPN handshake would look like this. It's just going to use two connections. The client is going to send out that it's using the ALPN extension and then a list of protocols that it supports. The server will then go ahead and reply back with a hello, stating that it supports whatever the highest level of security is on the list, and also with the selected protocols. So if they both support H2, they'll go ahead and connect over that and then choose which protocol and which cipher level to use, kind of like regular TLS does. So basically, we'll look at the current security landscape. So some of the WAFs, and I use some very lightly, now support HTTP2. So I've really only gotten 2 responses back from WAF companies when asking, do you support HTTP2? 2 companies came back and said, yeah, we support HTTP2. A few of the WAFs just say that they have experimental support, but you basically need to be on the most cutting, bleeding edge version of their product. So maybe they support it, maybe they don't. Security tools. So currently there's only one proxy that I found that can record any HTTP2 traffic. None of the DAS tools out there support HTTP2. And we're basically limited to tools like HTTP2 Fuzz, which Yahoo rolled out, and Wireshark. So if you want to do any sort of research on this, be prepared to learn Go, and be prepared to hate yourself after you learn Go. So then the question is, well, how do I even know HTTP2 is running then? So good question. So basically there's 2 methods that I'm going to cover. One is one-off methods. So the first method is you can actually use Firefox. There's really no UI elements anywhere that tell you that you're using HTTP2. So you're going to end up using web developer tools. And it'll check the response headers and see what you get back from the server. The response will be HTTP2, as you can see right here. And Firefox will actually insert its own header in there with the x.firefox.spidey as shown here. The next method is via Google Chrome extension called HTTP2 Spidey Indicator, which you get a nice little blue lightning bolt whenever you visit a page that supports H2. And then there's also some online tools. This one's called tools.cdn.com /H2 test. So basically, you just type in your URL, it'll reach out, and it'll tell you whether or not your site supports it. And the other fun thing too that I like about this site is you have this little public checkbox right here. So if you're kind of lazy like me, people kind of just test their own stuff for you, as you can see here. So you might want to uncheck that checkbox. Next way to check is with OpenSSL, which is kind of an underrated tool in my opinion. So you're going to use the next Protogen, I think, script. And that's basically the script that you're going to run with an SSL. And you're going to basically get back what the server supports. And this is basically looking at the ALPN handshake. Next one is a little application. It's called IS HTTP2-CLI. And you're going to have to install Node JS or NPM. I'm not a big fan of NPM, so kind of take your chances with that. It's only good for one URL or IP at a time. It's easy to use. It has fairly good output, and I have the GitHub link there. And basically, you're just going to type in IS HTTP2 and the URL, and you're going to get a nice little green check mark, and it'll tell you that it's supported. And again, it'll give you the APLN extensions that it supports. Just kind of throwing it in there, curl also works as well. But it only works if you add the ng HTTP2 library. And you can tell curl to use HTTP2 either plain text or over TLS. You have to use the HTTP2 option. Or else curl will default to HTTP 1.1. And you can also use libcurl 7.44.0. The next method is using ng HTTP2 with the ng HTTP-NV option. It'll go ahead and tell you the negotiated protocol at H2. And I also like it because it'll give you a bunch of connection information, header information that you would get back from a server. Next is the man-in-the-middle proxy, which is, again, going back to the only proxy that will support it. And as you can see that it's using HTTP2 on there. And kind of a big bummer is that Burp dropped any support for any additional headers. So when you're testing with Burp, you won't even see the 101 or the upgrade connection. They actually took that out for some reason. So that's a little sad. And then basically you're looking at like Wireshark as well, where you can see that it'll show you that you're capturing packets on H2. So the next one is detection at scale. So the first tool that you can use is called H2 scan. And again, I hope you like Go to go ahead and use this. You're going to just use a... Alrighty. The microphone doesn't like me. So you're going to use echo, and then you're going to list all of the sites that you want to see to the /H2 scan script, and then it will go ahead and tell you whether or not it supports H2, Speedy, or HTTP. Mmap does a pretty good job. Does a pretty good job as well. You just use nmap-p443 and run the script. It can be used for large amounts of URLs and IPs. However, it doesn't work well with H2C. So basically, a tale of two VPSs. So we're going to kind of go into a little bit of story time about how I went ahead and tried to discover H2 at scale. And some of the fun that I had with the VPSs that I tried to use. VPS 1 is Google Cloud. So Google Cloud has some pros. They'll give you a $300 credit for signing up, and you have your choices of VMs. You can get Debian, Ubuntu, CentOS, or CoreOS for about $24 a month. The cons with doing that is you basically end up with limited VM size. It's really super slow. The support is slow. It's tier 1. They'll take several days to get back to you if you have any questions. And it's all over email. And I can contest that they are not security researcher friendly. So if you're going to use Google Cloud for any sort of scanning or testing, be prepared to sit at your email like this. And you're going to have to file an appeal with Google and their compliance team. And it says 3 days, and they will take the entire 3 days to get back to you. So you're kind of wondering, do I back my stuff up? Are they going to shut me down? You don't really know. So basically, you just send them a little reply, and you say, hey, I'm a security researcher. I'm not doing anything bad. Let me keep doing this. And the response works pretty well. They'll turn your VM back on and tell you to fix some compliance issues. And this response works very well until it doesn't. So basically, they will shut you down, and really they don't tell you why. And I kind of just think that if the compliance guy that's reading your email is having a bad day and had to sleep on the couch that night, he's just like, no. And he just completely shuts you off. So basically, after getting this email, to get turned back on, you're just going to basically have to hound the crap out of support and compliance for several weeks. And they'll basically turn you back on. However, I think I can say that I have the distinguished right to say that I've been completely banned from Google Cloud. So VPS number 2 is one called Ultra VPS, which I love. So maybe they'll see this and give me some money for endorsing them. So it's basically pretty cheap. There's two low-end plans, $10 and the $20 a month plan. It's self-service, it's easy to set up, and they're very security researcher friendly. So I kind of look at them as like the honey badger of the VPSs. They just don't give a shit. I tried both the $10 and the $20. So if you're going to do any sort of scanning or anything like that, the $10 one was pretty horrible, and it shows that it's comparable. However, I'm going to definitely recommend the $20 one. You're going to get about 4 GPs of RAM, 50 GB of storage, bandwidth, and an IP address. And they've been pretty awesome about it. So that's been pretty good. So what was I doing with these VPSs? So the first thing I did is, we're looking at mass scan. So mass scan is pretty cool because you're able to find all the IPs listing on port 443 quickly. So the first run on the $10 VPS took me about, I'm going to say a week. The second one that I ran it on took probably a little less than 48 hours. And also, just full disclosure, it was just a complete YOLO scan. There was no blacklisting because we wanted to kind of get the full scope of what actually was running out there. The cons is that it doesn't really support the Nmap scripting engine at all, so it's not really able to find H2 or H2C. So basically, what did I find? I found about 49 million IP addresses, almost close to 50 with port 443 open. However, I ended up with this like 20 gig XML file, and I wanted to get the IPs out. I'm lazy in a sense. I hate grep. So, and I hate myself again. So what did I do? Built a script. So if you happen to need a script in Python to take stuff out of mass scan XML to IP and basically put it in a nice, neat text format, you can find it here. So once we get the findings with mass scan, the next step is to go ahead and get Nmap and use the scripting engine. So again, I just brute force things. I'm not very gentle. So when you use T5, to go ahead and look, it still is pretty slow. It took over a week to run on 49 million IPs. And I really only found about 300,000 instances running HTTP2. And just a quick kind of shout out, an honorable mention for this. Rapid7 kind of changed the name of their project Sonar to Open Data, and it really has some pretty awesome data in it, but it doesn't support H2 at all. But you can always use the system found in HTTPS scan data as a starting point of things to test if you really don't want to use mass scan. And it all comes in a super small 50 gig file. So the next method I used was Showdown. Showdown's pretty cool because it's easy to use. You can basically find it using the ssl.alpn h2 in the search bar. And so searching is absolutely free. Creating a report is free. But the cons is you have to pay to download the results, and that can get pretty pricey. It takes about a long time to download results. It took about 3 days, plus or minus, to download the 3 million IPs. And even when you do pay, you can't download, or you can only download 1 million results. So basically the fire hose results are only available to enterprise customers, which was a little disappointing to me. So really, what did we find on Showdown? So basically I took 2 separate snapshots to kind of show you HTTP2 adoption. So at the top, you can see we have about 2.3 million sites that were using H2 on the 14th of February. And that actually jumped to about 3.6 million just a couple months later. So it's definitely gaining traction. Just to kind of show you some of the report info, top countries are the US and China. Looking at the top organizations, Cloudflare is really huge, and so is Amazon. And kind of looking at it, the top products are Nginx. So that would really kind of make a lot of sense since Cloudflare loves Nginx as their CDN kind of server of choice. With Ideal Web Server coming in second and Apache at a third. Top domains are Amazon AWS, then Unified Layer, and then home.pl. So basically, the next thing is really what was found. In short, just a bunch of DDoS. It's just everywhere. So to kind of look at just the passive findings, we ran into the slow read attack, which is CVE 2016. Note that it is from 2016. And we found about 7,000 systems on Apache, just out of the 1 million scanned. And it's basically like a slow LoRa's DDoS attack. And it calls on a malicious client to read responses very slowly. The HPAC bomb, kind of what I was talking about earlier with the header compression, really only found 29 out of 1 million systems that were vulnerable to this, as well as Wireshark. And it's basically a compression layer attack that resembles a zip bomb attack or a decompression bomb. HPAC is used to reduce the size of packet headers, basically the sender can tell the receiver the maximum size of the header compression table, and can decode the headers. And basically, you're just using innocent-looking messages that can actually unpack into gigabytes of data on the server and basically consuming all of the server memory and either slowing down or crashing the system. Dependency and priority attacks really only found about 29 out of 1 million systems, 36 out of 1 million on Apache. It leverages the flow control mechanism that we were talking about earlier with H2. Yeah, I'm going to have to put this down here, I guess. So basically, the client can use specially crafted requests to prompt a dependency cycle and forcing the server into an infinite loop. HTTP streaming multiplexing basically affects Windows 10 Gold and 1.1511. Really don't know how many are out there. I didn't really see a whole lot of IIS out there when doing the scans. So basically, I think the hardest part was when looking for stuff like this, just to when looking for this stuff is a lot of people like to put really fun things in their server headers or giving you generic or something like that. So it's kind of hard to tell. But I did notice a lot of really old, crappy stuff in AWS, just as a side note. So basically, how do we prevent future attacks on H2? Recommendations are patching, updating, and staying current on your OS and not leaving old, outdated stuff out there. If you don't need it, essentially turn it off. You have options to turn it off at the server level, on the WAF level, and also at the CDN level. And also, Google actually has a really cool document for security best practices. that give you lots of options to go ahead and configure your H2 instances to be a little bit more secure. So a lot of that, like I said, this is part one. There's a lot more coming in part two for messing with really fun security misconfigurations. And basically limiting DOS attacks. You can limit the rate of requests from a single user, limiting the number of connections that can be opened by a single client, and closing connections more quickly with more aggressive timeouts. Just as a side note, HTTP2 will actually open a connection, and it actually will never close it. So it's always recommended to actually put in a timeout because it does not do that by default. Some other resources that I've come up with. The first one is a link of info and really good testing tools. Developers are really helpful with any sort of pen testing or security research because they provide us with a bunch of tools that were meant to be used for testing, but you can actually use them to do some pretty creative and fun DOS attacks and other sort of attacks. The second one is just testing tools. Third is known HTTP2 implementations. So it's basically a really nice list of technologies that support HTTP2. And the last but not least is the HTTP2 RFC. So the people that actually came up with HTTP2 knew that there was going to be a bunch of vulnerabilities and misconfigurations. And that link will actually take you to a good amount of suggestions and pitfalls that H2 has. So, and again, I guess to go back up to the top link, if you want to use testing servers or anything like that, there's actually a bunch of good resources on how to spin up your own H2 instance and things like that. So basically, it's Q&A time. So basically, if you have any questions, the answer is definitely going to be aliens. So does anybody have any questions, comments, death threats? What's that? Did you guys learn anything today, at least? If people are going to walk away and say, okay, I learned something? Okay, good. All right, well, if you guys did have any questions and maybe you were too afraid to ask, you can always direct message me at SecurityPanda on Twitter or at panda@securitypanda.io. Questions, comments, if I missed anything, anything like that. Oh. What sites would I look at? So, like testing against them? Yeah. I think you could probably use Google or Twitter or something like that if you're just doing passive. You know, or again, anything that's behind Cloudflare or something like that. Those usually, you know, you'd hope that they're using the best practices on that. So we can talk about it too, more if you want. Does anybody? Okay. I mean, really, when you look at like kind of security as a whole anyway, for application security, just having anything in clear text is usually not a good idea, but if you're just using really static content, you know, it's kind of like that way off, but for me, it's like if you're just using static content that has no user interactive content on the page, then maybe. But it's kind of always up to your best judgment. And for me, I'm always a fan of using SSL over plain text. Anybody else have any questions, comments? No? Okay. Awesome. Well, come up and have some dumpster fire. Thanks.